Hello and welcome back to College Algebra, MAT 150. In this lecture we're going to be discussing solving logarithmic equations. So many logarithmic equations require you to combine multiple logarithms and coefficients together using the laws of logarithms from the previous section. Then after you combine, you can use one of the methods that we talked about in when solving exponential equations. So we can either make the two sides look the same, or and then set the insides or logarithm or the insides or the exponents equal to each other, or we can use inverses or equivalent equations to solve. So let's start with this most basic one. But before we start with this, we need to note one thing. We need, when we're solving for exponentials, we solved and we were done. But logarithms can't have negatives on the inside. So your solution can't produce something that has a negative like that. As such, because that's outside of the domain of those logarithms. So as such, you have to check your answers, at the very least by plugging them back in to see if you have negatives for the insides of the logarithms. So if we look at number 1, ln of 3x plus 1 equals ln of 2x minus 3, that can only be true when 3x plus 1 equals 2x minus 3. Again, it's the idea of setting these look the same, so we set the insides equal to each other. So we start solving, subtract 2x from both sides, subtract 1 from both sides, and we get 3x minus 2x is x, and then negative 3 minus 1 is negative 4. And then we can simply check our solution, and we just need to plug it in on one side as it turns out. 3 times negative 4 plus 1, again we just need to check the inside, and we get negative 12 plus 1 equals negative 11, which again we can't have a negative on the inside of a logarithm. Even if it's a negative on the other side, on the other logarithm as well, we can't have it. Okay, so just if it happens one time, then we know that we can't use it as a solution. So x equals negative 4 is not a solution, so that was the only possible one we could have. So since there are now no more solutions, we say no solutions as our final answer. For number 2, we can look at, we have ln of x squared minus 5 equals ln of x plus 1 plus ln of x minus 2. For number 1, we had ln equaled ln. That was it. So we need to rewrite this right side over here as one logarithm. And outside addition turns into inside multiplication. So ln of x plus 1 times x minus 2. And then just like before, the only way that ln of x squared minus 5 can equal ln of x plus 1 times x minus 2 is if the insides were equal. We can now multiply this out, and when we do, we get x times x is x squared. We get 1 times x is 1x. X times negative 2 is negative 2x. Combining them, we get minus x. 1 times negative 2 is negative 2. And we try to isolate or get everything to one side, so x squared, subtract x squared, and all of a sudden we're left with negative 5 equals negative x minus 2. So let's get the x to the other side. So x minus 5 equals negative 2, then add 5 to both sides. So x equals 3. We have a potential solution, x equals negative 3, but we have to check. So if we plug in 3, so since we have a logarithm for all those, we have to go back to the original equation. We're literally just going to test it for all of those. ln of 3 squared minus 5 equals ln of 3 plus 1 plus ln of 3 minus 2. Oh, let's expand that over there. And then we get, so 3 squared minus 5, that 3 squared is 9, minus 5 is 4. 3 plus 1 is 4. and then 3 minus 2 is 1. So we have nothing but positive numbers in each of these, so this is perfectly fine. And further, you could go actually all the way through the confirmation. ln of 1 is 0, so we actually have ln of 4 equals ln of 4. So it proves it's a full solution as well. All right, so x equals 3 is our only solution there. All right, so we now move on to number 3. So number 3, we have log base 3 of x plus 2 equals 2. But like before, we had ln of 3x plus 1 equals ln of 2x minus 3. We had ln's on both sides. Here, we don't have a logarithm on both sides. So what we have to do, we can't use that mechanism like we did. We have to use the equivalent equation method of solving. So a logarithm with a base 3 would have an equivalent equation of an exponential with a base of 3. The output of a logarithm is the exponent, and then inputs for logarithms and become outputs for exponentials. So 3 squared, which is 9, equals x plus 2. Then we start solving, subtract 2, and we get x equals 7. And if we plug in 7 and we add 2, that is 9. That's positive. That's all we had to check. It never hurts to check all the way through, but we only have to check so far as to make sure that the inside is positive. All right. So now we come to 4. We have 3 times log of 3x plus 1 minus 1 equals 8. For all the previous ones, 1, 2, and 3, we had the logarithms already just isolated. Here, the logarithm, log of 3x plus 1, is not isolated. So we have to do so. We're going to start by adding 1 to both sides. So we get 3 log of 3x plus 1 equals 9. And again, it's still not isolated, so we got 3 times the log, so we divide both sides by 3. And now we have log of 3x plus 1. 9 divided by 3 is 3. Now the logarithm is isolated. What's the base of the logarithm? 10. So we can use the equivalent equations method. And so we have the equivalent equation of the logarithm with base 10 is an exponential with base 10. The output of the logarithm is the exponent, and the input of a logarithm is the output for the exponential. 10 to the third power is 1 with 3 zeros after it. We continue solving for x, so subtract 1. So we get 999 equals 3x. And then we finish this by dividing by 3. So we get x equals 333. All right. And if we plug in 333 back into here, we just need to plug it into the logarithm. Times 3 is 999 plus 1 is 1,000. So we verified that this solution is valid. All right. So for number 5, we have log base 8 of x plus 1 plus log base 8 of x minus 1 equals 1. Just like here, we need to have the logarithm isolated. However, it's different in this mechanism. The logarithm isn't isolated. We have 2 of them, but they have the same base. Again, that's what's required to be able to combine them. So log base 8, so we can rewrite this. Log base 8 outside addition turns into inside multiplication. And now we have log base 8 of x plus 1 times x minus 1 in bracket equals 1. And we can rewrite this as an equivalent equation. So a logarithm turns into an exponential with the same base. The exponent is the output of a logarithm, and the input for the logarithm becomes the output for the exponential. We have 8 equals x plus 1 times x minus 1 is x squared minus 1. It's a difference of squares factor. And we solve however we sort of want to. So we can add 1 if we want. If you want to go the square root route, so x squared, so I'm just swapping here, 8 plus 1 is 9. Then square root both sides, and when we do, we get plus or minus the root of 9. And so x equals positive 3 and x equals negative 3 are our possible solutions. But if you quickly see, if you plug in negative 3 plus 1 is negative 2, which means we would have a negative inside here. So this solution doesn't work. But if we plug in 3 here, 3 plus 1 is 4, 3 minus 1 is 2, both of those are positive. So in this case, we had 2 possible solutions, but this one didn't work. The x equals negative 3 didn't work, but x equals 3 does. That concludes this lecture and this section.